Welcome in this video. This is a third chapter NCERT 9 class, and this chapter is about atoms and molecules. Let's start. Ancient Indian and Greek philosophers have always wondered about the unknown and unseen form of matter. The idea of divisibility of matter was considered long back in India, around 500 BC. An Indian philosopher an Indian philosopher an Indian philosopher Maharshi Kanad postulated that if we go on dividing a matter, we shall get a smaller and smaller particles. Ultimately, the stage will come when there shall be we shall come across the smallest particles beyond which a further division will not be possible. He named these particles Parmanu. Another Indian philosopher, Kanad Pagudakatyayama, elaborated this doctrine and said that these particles normally exist in a combined form in gives us which gives us various forms of matter. Okay, and we will be only discussing the important things in this video. Let's discuss about the law of constant proportion. Water in a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water. Thus, if 9 gram of water is decomposed, 1 gram of hydrogen and 8 gram of oxygen is always obtained. How it is like H2O? Like in H2O, it is a molecular mass of 8 and it is a 1. So it has a 2 molecules of oxygen. So it will be 16. Sorry, it has an atomic number of 1 and mass is 16. And it has a atomic number 1 and mass is also 1. And since hydrogen, there are 2 hydrogen atoms, so the whole compound have a ratio of 2:16 of mass, and it will be simplified as 1:8. Who is a Dalton? Let's discuss about it. Dalton was born in poor weaver family in 1766 in England. He began his career as a teacher at the age of 12. 7 years later, he became a school principal. In 1793, Dalton left Manchester to teach mathematics, physics and chemistry in a college. He spent most of his life there teaching and researching. In 1808, he presented atomic theory, which was the turning point of the study of matter. According to Dalton's atomic theory, all the matters where element and compounds are mixed, compound or mixture is composed of small particles called atoms. The postulates of his theory may be stated as follows: all the matter is made up of tiny particles called atoms. Atoms are individual particles. Atoms of given element are identical in mass and chemical properties. Atoms of different element have different masses and chemical properties. Atoms combine in a ratio of small whole numbers to form a compound. The relative number and kinds of atom are constant in a given compound. Let's discuss about what is an atom. You have ever observed the mason building walls? From these walls, a room and then collection of rooms to form a building. What is the building block of the huge building. What about the building block of an ant hill? It is a small grain of sand. Similarly, the building block of matter are atoms. How big atoms are? Atoms are very small. The atomic radius is measured in nanometer, 10 to the power 9 meter. And here is its relative size, 10 to the power 10, which is 10 angstrom. Atom of hydrogen, the molecule of water is this much radius, and 10 to the power this much big is molecule of hemoglobin. Grain of sand is 10 to the power 4 meter. Ant is 10 to the power 3. An apple is 10 to the power 1. And Dalton had proposed some symbols to represent the atoms: hydrogen for this, oxygen for this, mercury for this, lead for L, and so. In the beginning, the names of the element were derived from the names of place where they found for the first time. Suppose copper was first found in Cyprus. Cyprus is a little island nation in the Mediterranean Sea. Gold was taken from the English word yellow. And hydrogen. Iron Fe from its Latin name ferrum. Ferrum means iron, so that is why the chemical symbol is Fe. Sodium Na from the natrium, and potassium case for kalium. There are again atomic symbols: aluminium Au, argon Ar, barium Ba, boron B, bromine Br, calcium Ca, carbon C. Okay, let's discuss about atomic mass. What is atomic mass? Atomic mass simply is a number of proton and neutron in an atom. One proton and one neutron has a almost 1 AMU, atomic unit, and total number of proton and neutron is called atomic mass. But however, in science we have defined it a different way, which is like however, in 1961, a universally accepted atomic unit is carbon-12 isotope. One atomic mass unit is a mass unit equal to the exactly 1/12th mass of the one atom of carbon-12. See, carbon-12 has carbon-12 means it has a 6 neutron and 6 proton, and this whole mass will be 112. So its mass will be 12, and if we divide it by 12, it will become 1. So this will be like 1/12 of the atomic 1/12 of the mass of the one atom of the carbon C12. This is 1 AMU, atomic mass unit. Oh, sorry. And atomic mass is hydrogen has 1. Why? Because it has only a proton in its nucleus, it doesn't have a neutron. Carbon has 6 proton, 6 neutron, although it has different isotope, but we're discussing about the C12 isotope. Nitrogen, its atomic number is 7, and 7 proton and 7 neutrons makes it atomic mass 14. Oxygen has atomic number 8 plus 8 is 16. Then sodium, magnesium, then chlorine. Why the chlorine has 35.5? We will discuss this later. This may be an important question. Why do atoms exist? What are molecules? Let's discuss about the molecules. A molecule is a general A molecule is in general a group of two and more atoms that are chemically bounded together. See, if the two and more atoms are chemically bounded together, suppose oxygen, one oxygen are chemically bonded together with a maybe whatever bond could be, then it forms a molecule. Suppose hydrogen and oxygen chemically bonds and it forms the molecule which is called water molecule. Molecules of element. Molecules of oxygen consist of two atom. So molecule of atom means suppose an element is naturally found in couples or in two. So this means a molecules of oxygen consist of two atoms of oxygen and hence it is known as diatomic molecule, O2. Also we have ozone which has a chemical formula of O3. The number of atoms constituting a molecule is also known as atomicity. So we have a atomicity here. Argon is single and monoatomic. Helium is again monoatomic. Why they are monoatomic? Because they are their valency is zero. If some atom has a valency, it always try to combine with another to with a bond so that it reach in a stable position. So valency can be completed. So oxygen, diatomic, hydrogen. See, hydrogen have one valency, and so one more hydrogen attaches with it, so it forms with covalent bond. So it forms S2, diatomic, two atoms of hydrogen. Similarly, that nitrogen is diatomic, and chlorine is again diatomic, and there are some tetra and polyatomic also. Molecules of compounds. See, molecules of element we have discussed. We are only discuss about a single element forming a molecule. Now we are discussing molecules of compound means different elements are forming molecules. Different elements like for example oxygen and hydrogen here forming a water and the ratio of mass is 1:8 as we just discussed above, and ammonia NH3 when the nitrogen and hydrogen two atoms are forming it. Similarly carbon dioxide, carbon and oxygen. What are ions? The third category. The compound composed of metals, non-metal contain charged species. Something is charged which is ions. A charged species are known as ions. Ions may consist of a single charged atom or group of atoms that have a net charge on them. An ion can be negatively or positively charged. A negatively charged ion is called anion and positively charged is called cation. Take example of sodium chloride. Its constituent particles are positively charged sodium Na and negatively charged chloride ion Cl. Writing about the chemical formula. See, let me further elaborate it this one. Ions. What are generally ions is, suppose an atom is electrically neutral. Why it is electrically neutral? Because electron have negative charges and proton have positive charges. In an atom the number of electron and proton are same, so all the positive and negative charges makes the electron neutral. Suppose that if he gains few more electron, so the more electron it will get, the more negative charge it is getting, the atom will overall will get a negative charge, and negative charge is for anion. And suppose if an atom releases its electron, so overall only the electron negative charge is released to atom, there will be the more protons compared to the electron because some electrons are already out of the atom. So overall the atom will be a positively charged. So this is how the charge represents the ion. Writing a chemical formula. Let's talk about the chemical formula. The combining power or capacity of an element is called valency. Valency is a combining power. Name of the symbol of the some ions. These are ions. See, H plus Na plus, and what does Na plus means? Sodium, generally a Na, and it must have its one of electron is not in its atom, it is outside the atom. So one electron decreases to totally, like, uh, as the number of electron and proton was equal, so one electron become less, so one charge which is a one positive charge which is of one proton, uh, makes the whole atom Na plus 1 plus. If there is two electrons are gone, then the atom will be plus 2, and vice versa in case of is in negative. This o is negative, O2 is negative. That means oxide has taken two electrons in its atom. So overall, two electron formed this negative charge. Formula of simple compound. So simple compound we generally have, see, formula how to this is a valency, as hydrogen has one valency and chlorine has one valency. They goes this way and they will form. See, hydrogen also need uh, one bond to become stable, and chlorine also want one bond to become stable. So they both need one guys. So they attaches, so they form hydrogen chloride. In case of hydrogen sulfide has a two, so it needs two thing. Matlab two, it has a two valency and hydrogen have one valency. They attaches this way. So one s one sulfide needs two hydrogen atoms, and because one hydrogen has the one valency, so that it goes this way. And tetrachloride, chlorine, carbon has a valency of 4, chlorine has a 1, so a 1 carbon need 4 chlorine. This magnesium chloride, again this is a positively and negative. The positive and negative charges must balance each other and the overall structure must be neutral. Some more examples. Aluminum oxide, aluminum charge is plus 3 and oxygen charge is minus 2, so it combines this way. Then calcium oxide is there, sodium nitrate and calcium hydroxide. OH group is called hydroxide, and NO3 is called nitrate. CO3 is carbonate. Sodium carbonate, we have another example of aluminum sulfide. Let's discuss about the molecular mass and mole concept. A molecular mass of a substance is a sum of the atomic masses of all the atoms in a molecule of a substance. Okay, so let's find out the atomic mass of a water. Hydrogen has a 1 atomic mass and oxygen has 16, 8 proton and 8 neutron. So 2 hydrogen and 1 oxygen, 18. So H2O has 18 atomic mass. Similarly, we can find out HNO3. It is simple. Formula unit mass. A formula unit mass of a substance is a sum of the atomic masses of all the atoms. Sum of the atomic masses of all the atoms in a formula unit of a compound. Formula unit mass is calculated in the same manner as we calculate the molecular mass. And formula unit mass of calcium chloride. Atomic mass of calcium plus there are two molecules of chlorine, so 2 into atomic mass of chlorine. As I discussed only, we will discuss later why chlorine has 13.5 as a atomic mass. Now discuss about the mole concept. Mole is just a number, like we see 1 dozen. 1 dozen contain 12. Okay, one pair of shoes contain 2 shoes. Similarly, the mole concept is a number of substance, number of things. So therefore, there is more convenient to refer to the quantity of a substance in terms of number of its molecule or atoms rather than their masses. So a new unit, mole, was introduced. The mole symbol, mole, is the SI unit of amount of substance. This is amount of substance. Like 1 dozen of banana contain 12 bananas. Similarly, 1 mole contains exactly 6.022 into 10 to the power 23 elementary entities. What are entities means? It is also described herein. So this number is a fixed numerical value. This number is a fixed numerical value of the Avogadro's constant. So this is also called Avogadro constant, this number. Elementary entities may be atoms, a molecule, ions, an electron, any other particles or specified group of particles. The mole is an amount of substance of a system that contains 6.02214.076 into 10 to the power 23 specified elementary entities. 1 mole of anything equal to this, like 1 dozen is 12 in number. 1 gross is called 144 nose. Molar mass of an atom is also known as gram atomic mass. What? The molar mass of atoms is also known as gram atomic mass. For example, atomic mass of one hydrogen is 1 AMU. So the gram atomic mass will be 1 gram. So that means 1 U hydrogen has only 1 hydrogen atom, and 1 gram hydrogen has 1 mole of atoms, that is 6.022 into 10 to the power 23 atoms of hydrogen. Similarly, 16U oxygen has only 1 atom of oxygen, and 16 gram of oxygen has 1 mole of atoms, that is 6 this number 6.022 into 10 to the power 23 atoms of oxygen. So it is easy. Suppose we have 1 gram of oxygen, that means we have 6.022 into 10 to the power 23 atoms of oxygen. We keep the numerical value the same as the molecular mass, but simply change the unit as above from gram to U to G. So what is this Avogadro's number is doing? It's see, AMU, it is hard to measure atomic mass unit, which is just 1 mass of a proton or a neutron. So it is only changing the unit from U to G, gram. 18U of water has only 1 molecule of water. 18G of water has 1 moles of water, that is, it has 6.022 into 10 to the power 23 molecules of water in 18 gram of water. Similarly, in 32 gram of water will be 36 gram of water, it will be twice 2 moles. 36 gram of water contain 2 moles of H2O molecules. 2 moles. 1 mole is this number. 1 mole equal to this number. Relative mass in grams. The word mole is introduced around 1896 by William Ostwald. The unit mole was accepted in 1967. We have almost finished this chapter. Let's revise it. During the chemical reaction, the sum of masses of reactant and product remains unchanged. This is known as law of conservation of mass. In a pure chemical compound, elements are always present in definite proportion by mass. This is known as law of definite proportion. An atom is the smallest particle of the element that cannot be usually exist independently and retain its chemical properties. That exist independently, that cannot usually exist independently and retain all the chemical properties. A molecule is the smallest particles of an element or a compound capable of independent existence under the ordinary conditions. It shows all the properties of the substance. A chemical formula of a compound shows its constituent element and number of atoms of each combining element. Cluster of atoms that acts as an ion is called polyatomic ions that carry a fixed charge on them. A chemical formula of a molecular compound is determined by the valency of each element. So chemical formula is determined as per the valency. Ionic compound. In ionic compound, the charge on each ion is used to determine the chemical formula of a compound. So see, ionic compounds, what happen? The charge of an ion, charge on each ion is used to determine the chemical formula, and in non-ionic compounds, the valency of each element determines the molecular formula. It's all about the stability. Suppose carbon has a 4 valency, so that means carbon needs 4 bonds and 4 entities which has 4 things, 4 entities, so that it can chemically become stable. Either 4 hydrogen can be there. If something which has 2 valency, some element which has 2 valency, then the carbon will need two set of these two entities to get stable. Avogadro constant 6.022 into 10 to the power 23 is defined as a number of atoms in exactly 12 gram of carbon. 12. 1 mole of amount of a substance is of a system that contains 6 itna Avogadro's number specified elementary entities. 1 mole of substance is called 1 mole of a substance. The mass of 1 mole of a substance is called its molar mass.